with the H value. H value is the horizontal component of the magnetic field. Remember the H part of it? Yes, that is minus 23 units. Right? Generally the unit is Tesla, or you can say microtesla. Yes.
Okay.
50. You have to find out the value of Z and T. Find Z and T. So the magnetic dip at 40 degrees with horizontal component H is equal to minus 23 units. So the horizontal component is minus 23 microtesla, and the magnetic dip is taken at 40 degrees. You have to find out the value of Z. What is Z?
Dip.
No. So let's look at the compass here. Again.
Vertical component.
That's right. So the compass always is in line with the total magnetic field of the Earth, and we have the surface. The Earth's surface is straight underneath. We have seen this diagram yesterday, right? So since there is a bending of the equator, when you move out of the magnetic equator, the pole starts the north-seeking pole of the magnet starts pointing towards the north pole. Or if you go to southern hemisphere, then the south is going to the south-seeking, or the north pole of the magnet is going to point towards south pole of the Earth, right? And that is what causes dip. We saw that yesterday. Now this has two different components. You can resolve this into two components. The perpendicular component which is parallel to the Earth's surface is the horizontal component, which is H.
Yeah.
And also there's a resolved vertical component which is perpendicular to the Earth, which is Z. The angle made by total component, total magnetic flux of the Earth with the horizontal component, this angle is what is called as angle of dip, which is theta. Right? Therefore Z is the vertical component and T is the total magnetic field. Right? What is H? H is the
Horizontal component.
horizontal component. We also saw yesterday using trig functions, so trigonometric functions, you can find out H and T. What is H? H is the adjacent side towards theta, therefore H is equal to
T cos theta.
T cos theta. Right? And what is Z?
Yeah, T sin theta.
Yeah, Z is the opposite side. It is T sin theta. Right? Here, dip is at 40 degrees with H is equal to minus 23 degrees unit. So dip angle is given at 40 degrees, which means this angle is 40 degrees. H is given as minus 23. Then what is the meaning of? So why is minus? Oh, sorry. It's 23 units. Just corrected. I was wondering why it's minus. Right. H is given as 23 units. You're asked to find out the value of Z and T. Can you find out? Right? Yes. So H is equal to
H is equals to 23
cos theta.
T cos theta. 23 is equals to.
Yeah. T is equal to.
That also I can do that. Is equals to H by cos theta.
What is H?
So H is 23 divided by cos 40.
Cos
30.
How much?
30. 30.
30.
30 decimal 0.
Units. The unit is usually microtesla. 30 units. Right? Now, how will you find out Z? Once you have T in place.
That is T sin theta.
T sin theta. Or you can do it in a different way. You can find the tan theta out of the triangle. So tan theta is equal to opposite side divided by adjacent side. So that's going to be Z by H. And since you know the value of H, it is 23 tan times 40. You can find that way as well. The total component is found out to be 30 here.
25.
30 sin 40. How much is it?
30 sin 40, no? 19.
19. If you find using tan theta, then Z is equal to H tan theta. H is equal to
30.
23.
Achha, H is okay, not 30.
23 tan 40.
Again same 90.
90. So you can use either of the equations, trig functions, that's up to you. But basically, as long as if you can understand this figure, you don't have to by heart any of these. You can just kind of derive all these things every single time. So it's a very good idea to derive the equations every single time than by hearting it. So at the end of the day, after doing 10 questions, the equation will automatically be there in your mind than sitting down to by heart it. Right? Second advantage is, in the event that you have some confusion or you forget the formula, you will still know how to derive it.
Yeah.
Let's look at another question. Given the total component of the Earth's magnetic field is 50 microtesla. That's a unit. The dip angle is 60 degrees. Find horizontal component of Earth's magnetic field and the vertical component of Earth's magnetic field, H and T. So given the dip angle is 60, the total component is given. Can you very quickly tell me what H is? Since the dip angle is 60, 60 means it's more like cos 60 a function, and therefore it's going to be half, straight half, right? Therefore H is going to be 25, straight. Understood? Yeah. So here, let's draw a diagram again, just to make it in place. So we have the compass, total magnetic field T, and I can resolve this into two components. One of the components is actually parallel to the Earth's surface, which is H, and the other component is perpendicular, which is Z. The dip angle is the angle between the horizontal component and the total field is given as 60 degrees. The total component is total Earth magnetic field is 50 microtesla. So how do you find out H? H is equal to T
cos
theta. That's 50 cos 60. Cos 60 is 1 by 2, and therefore it's going to be 25 microtesla. So you can probably keep this in mind when the latitude is 60 degrees north or south of the magnetic equator, then the horizontal component will get reduced to half its value at the equator. Remember, H is maximum at the equator and 0 at the poles. Z is 0 at the equator, magnetic equator, and maximum at the poles. Right? Yes. Now what about Z? Z is equal to T sine theta. T is equal to 50 sine 60. Sine 60 is root 3 by 43 micro Tesla. Right? Make sense? Yes, perfect. So true heading is given as 359 degrees, variation is 3 degrees west, plus 2 degrees of deviation, and just find out heading in magnetic and compass.
So we are writing CD MVT.
Yeah.
We are given the true heading is 359 degrees.
359 degrees of true heading.
Yeah, variation we are given 3 degrees west. And deviation we are given as 2 degrees plus
2 degrees. What is that? What deviation is that?
That is basically 2 degrees east.
So easterly deviation of 2 degrees east. Yes. Yeah. So we have variation west, which means magnetic is west, right? So it's 359 degrees true.
Plus 3 degrees.
Yes. So how much will that be? 359 plus 3?
That will take me to 362 degrees.
Yeah.
Yeah, so 362 minus 360, that is 2 degrees.
That is 2 degrees. Yeah. So basically it is 359 plus 3, which is 362, and then 3 subtract 360 from that. So it is 2 degrees magnetic. Right? Alright, now what about deviation here?
Since deviation is in east, so our compass will be in least.
Least.
It will be in east. Yeah. So it will be 2 degrees minus 2 degrees.
That's right. So magnetic is 2 degrees, so 2 minus 2, which is going to be 360 degrees compass, or you can say 000 degrees.
Yes.
Degrees compass. If you just look at it straight as 2 degrees and 359, the tendency of thinking this to be more is high, so you should not think like that. 2 degrees is more like 362, and therefore this is less. or magnetic is more, for which the deviation has to be 3 degrees west. Remember, in such questions, the problem is, if you go wrong here, then since your compass is again dependent on this magnetic value, your compass also will go wrong. So just a chain, a cumulative thing, it goes wrong, back to back. Alright, yes, so you can write this question here. You're given variation is 5 degrees east. Deviation is plus 1 degrees. Compass heading is 70 degrees. Find. Heading magnetic and heading true.
And compasses we have 0, 7.
So 5 degrees east of variation and plus 1 degree deviation. So 1 degree plus 1 degree deviation is
1 degree east.
1 degree east deviation. Yes. What do you have? The base given as compass heading, which is
Compass is 070.
70 degrees. Yes. So what can you immediately find out is the magnetic one?
We start from deviation. So
That's right.
since deviation is in east, or compass is in east. If the compass is in east, so our magnetic is to be west.
Yeah.
So that is 70 plus 1, that is 071 degrees.
So you see here, the deviation is always applied directly to the compass. So it's 1 degrees east is plus 1 degrees. That's applied to 70 and you'll get 71 straight. Yes. Now with 5 degrees east variation.
Yeah, so 5 degree east variation means that magnetic is least. So again, it will be 71 minus 5 degrees. Okay, sorry, it's least now. Magnetic should be least from our true. So it is 71 plus 5.
Yeah.
It is 76 degrees. 076.
Be careful. Probably what you can do is after completing the table, just run through a table once again and see whether that is correct. So it's 1 degree east variation. See whether compass is least. Yes, compass is least. 5 degrees east variation. See whether magnetic is least. Yes, magnetic least. And for C, the addition is correct as well. 71 plus 5 is 76. Right? Yes. Well, this one you're given true heading is 260 degrees. Heading magnetic is 291. And deviation is minus 3. Find. Variation and
The magnetic is given.
compass heading.
Okay, compass. So again, we will be writing CDMVT. We are given true heading as 260 degrees.
True heading is 260 degrees.
Magnetic heading we are given 291 degrees.
291 degrees, yes.
Yes. And deviation is given minus 3 degrees.
Minus 3 degrees.
Yeah. So basically that means 3 degrees west.
Very good. 3 degrees west deviation. Yes.
So we are asked to find variation and the compass.
Correct.
So only the link is that we have magnetic and the true heading. If the true heading is like if magnetic heading is best, then true heading. So variation is to be west.
That's right. Magnetic is best, therefore the variation is west.
West.
And then we find the angular difference. 291
31
minus 60, which is 31. So 31 degrees west is your variation, the very high variation. And what about compass?
So since our deviation is in west, so our compass heading is to be west.
West, correct.
So if it is west, so it is 291 plus 3, 294 degree.
294. Let's check once again. 294, 291, the difference is 3 degrees. Deviation is west, means compass is the best, yes. the difference between 291 260 is 31 degrees, and since magnetic is best, the variation has to be best, right? So you have to do this check, just to make things clear, and make sure when you fill up the columns, the headings, don't just interchange the headings, right? All right. So the first part of magnetism is over. So 2 parts. The first part is what we just studied. The second part comes under instrument nav. Alright, so I'll leave you for now. You can go for your flight.